Hi guys, welcome back. Well, today for this lesson we are going to be looking at more solving quadratics by factoring. It's going to be some application problems, but we'll start with quickly reviewing all the stuff we just talked about, and that is solving the quadratics by factoring. So what's useful is that we can actually combine the two techniques. To solve a quadratic equation means to find its roots or x-intercepts or zeros. I will use all those three words interchangeably. Is zeros ES? Let's pretend it is. I'm not sure. Anyway, we can combine the different factoring techniques, different solving techniques we've used so far to kind of help each other out. So for example, we can factor and find the roots in order to help us graph. So for this first print, represent the following quadratic functions graphically using the x-intercepts and the coordinates of the vertex. Okay, well, there's actually some stuff that we can do here. So first of all, we can factor this pretty easily. Y is equal to x squared minus 4x. Algebraically, I'm going to find the roots. And then we'll take a quick look at a graph on Desmos to see how they kind of fit together. So I notice there's an x common to both of these guys. So it's going to be y equals x. Factor an x out of here, and I get x minus 4. My two roots are going to be x equals 0 or x minus 4 equals 0, which gives me x equals 4. So I've already solved this. There's my roots. So this point here, and 1, 2, 3, 4, that point right there, I've already marked them on my graph. Now, remember, these guys are equidistant from the axis of symmetry. So notice right there, dead center of them is the axis of symmetry. That also tells us the x-coordinate of the vertex. So we can actually find their midpoint. We can already see on the graph that it's x equals 2, but I'm going to actually show you how to do that algebraically right now. So you add together your two roots, so 0 plus 4, and divide it in half. So the formula is root 1 plus root 2 divided by 2 gives you the x-coordinate of the vertex. So you got a little xv there. And so that would be this guy, which is equal to 2. Remember to solve the numerator before you do the division, because otherwise you'll have a bad time. In this case, it actually doesn't matter. Every other case, it will. And then to find the y-coordinate of that vertex, you plug that 2 back into the original equation or the factored form. So I will say y equals 2 squared minus 4 times 2. There it is. So that's going to be 4 minus 8 is negative 4. So that's the y-coordinate of my vertex. 1, 2, 3, 4. There it is. And I'm just going to sketch a smooth curve as I can through each of my x-intercepts. That is not a good graph. It should have been more like this. Let's pretend I didn't do that first little part there. And that's roughly what it'll look like. And so if we flip over to Desmos really quickly here, and we plug the original form in, so it's y equals x squared minus 4x, and we compare it to the graph we just made, we'll actually see we nailed it in terms of the x-intercepts and the coordinates of the vertex. Let's actually write the coordinates of the vertex in here. So our vertex is 2 minus 4. And we should label it on the graph too. So 2 minus 4. And label our graph to x squared minus 4x. And that's an x-axis. That's the y-axis. Doesn't hurt to label our intercepts also. So this is 4, 0, and 0, 0. That's a nice detailed graph there, although it still has my ugly mistake on it. It's why you write in pencil. And there's all the details of the x-intercepts and the coordinates of the vertex that can be used to actually find the shape of the graph. We could have also used the step pattern, but we're not 100% comfortable with that concept yet, so we're not going to do that. Now, solving by factoring, we just talked about this, but there's some more advanced techniques. So first and foremost here, take a look at this one, part C I'm going to do. Notice I have to common factor. There's a 2 common to both of these. So it's 2 leaves me with x squared minus 49 equals 0. And now I can factor x squared minus 49 by recognizing that it's a difference of squares. If you must do the trinomial method, because that's all you know what adds to make this and multiplies to make that, then insert a plus 0x in the middle. And whatever the two numbers that you find must add to be 0 and multiply to make negative 49. But you will find that those two numbers are negative 7 and positive 7. which we could jump right into this answer because it is a difference of squares, or we also called it a product of sum and difference. See that? Sum and difference, right? Yeah. Which gives us the two roots, x minus 7 equals 0, which gives us x equals positive 7, or x plus 7 equals 0, which gives us x equals negative 7. There's our two solutions, roots. X-intercepts, zeros, whatever you want to call them. Okay, so there's a couple more practice ones. Remember, move everything to one side of the equal sign, so it's equal to 0, and then factor using regular techniques. Take each piece of the multiplication, set it equal to 0. We don't do that with the 2 because 2 equals 0 is a nonsensical statement. It makes no sense. So we're not going to do that. But here are some application problems. Woohoo! So here where we might have to work backwards. Isn't that exciting? Write a quadratic equations whose roots are 6 and minus 4. So we can construct our binomials from those. We know one's going to be x minus 6, and we know the other is going to be x plus 4. And then you can just put it into an equation. So y is equal to x minus 6 and x plus 4, and you can literally put in front of this bracket here, you can put any number you want and it will still suit that, and that will be important information for later. Here, let's do it again. So I'm going to actually work from the answer, x equals negative 2, and then I'm going to move everything to one side so it's equal to 0. So I get x plus 2 equals 0, and x plus 2 is the factor I will use. I did that because when I do the same thing with 2/3, I'm going to multiply up 3 to get 3x equals 2, and then move the 2 over to get 3x minus 2 equals 0, and that's where we get that factor. So the equation that we're going to get is y equals 3x minus 2 times x plus 2. And I'm just going to put a 7 in here because, I don't know, I'm a mean teacher and I like confusing my students. No, it's to illustrate the idea that, yes, you can actually use any number you want in front here, and it's all good. Here's an application problem. Woohoo! And so to find this, we would actually have to look for y-intercepts. We'd have to look for the x-intercepts, and we'd have to look for the distance between the x-intercepts and how far below would be the minimum value. So that's actually pretty neat stuff, but we are out of time for this video, so I'll do a short one running us through this, this application problem in a moment. Thanks, guys. I'll see you soon.